In this video, we exhibit a useful result for Laplace transform associated with periodic functions. If the function f of t is periodic with period p, and of course this relationship holds, a perturbation of time equals of f of t, then the Laplace transform is the integral from 0 to p of f of t times e to the minus st dt divided by 1 minus the exponentially decaying function e to the minus sp for s strictly greater than 0. We start with a definition of the Laplace transform. So we take the integral from 0 to infinity of f of t e to the minus st dt. And we can write this integral in multiple integrals from 0 to p of this function f of t plus the integral from p to 2p plus, so we split this integral in this way, involving the period p. Now, how can we write this? We write the first integral from 0 to p. And if we want to write these integrals from 0 to p, we just have to change the variables. So v plus p here, e to the minus v plus p dv plus from 0 to p to f of v plus 2p e to the minus v plus 2p dv plus the other terms. And so this, because the function is periodic, we can use this relationship here and switch back to the variable t. So it's from 0 to p integral of the function f of t e to the minus st plus e to the minus, this is s here, minus s p integral from 0 to p f of t e to the minus st dt plus e to the minus 2sp integral from 0 to p f of t e to the minus st dt, and so on. So we took the Laplace transform, we split from 0 to p, from p to 2p to appear to show the periods here and keep summing the other terms, and then we switch variables here. We keep the first integral from 0 to p, and then the second one. In order to get the bounds of integration from 0 to p, I just switch the variable v plus p instead of t. So it's t equals v plus p, and here from 0 to p, f of v plus 2p e to the minus v plus 2p s dv. And because the function is periodic, I use this relationship over here, and I have the first integral from 0 to p, then the exponential of e minus sp, the same integral here is here, plus e to the minus 2sp 0 to p integral f of t e to the minus st dt, and so on. Now is almost I have almost everything. So I write equal 1 plus e to the minus sp plus e to the minus 2 sp plus e to the minus 3 sp times the integral from 0 to p f of t e to the minus st dt. I took a common factor this integral here, and here I have the sum from j0 to infinity e to the minus sp and all of this to the power of j times the integral from 0 to p. This is an infinite geometric series, so I can write it 1 divided by 1 minus e to the minus sp times the integral from 0 to p f of t times e to the minus st dt. So the Laplace transform of a periodic function f of t is the integral from 0 to p f of t times the kernel e to the minus st dt divided by 1 minus e to the minus sp, where s is strictly greater than 0. And this concludes my proof.